I'm Stephen Bryant. I hold the Canada Excellence Research Chair in Materials Engineering for Unconventional Oil Reservoirs at the University of Calgary. Future generations may remember us for one legacy above all others: how well or how poorly our generation manages the transition to a more sustainable way of living. That's why my contribution to transformational research for a transformed world focuses on transitioning to a low carbon energy system. This transition will take decades, so we urgently need to reduce and even eliminate the carbon footprint of oil and gas used during the transition. Now, one way to do this: remove CO2 from the atmosphere and inject it into oil reservoirs. Now, in terms of efficiency, injecting CO2 is like clearing snow from your driveway with a teaspoon. But we've discovered a way to combine nanoparticles and soap-like chemicals that turn CO2 into a very stable foam. Think shaving cream, but much longer lasting. A startup company is commercializing this discovery and they're getting some traction. Here's why. Injecting foam is like clearing your driveway with a snowplow. It lets us store CO2 much more efficiently. We can even pull more CO2 from the atmosphere and put it into the reservoir than is emitted when we use the oil produced from the reservoir. That is transformational. It means we can eliminate the carbon footprint of oil produced that way. Now, our energy research has led us into unexpected parts of the transformed world. For example, during a collaboration that got microbes to convert crude oil directly into electricity, we figured out how to get microbes to turn themselves into a remarkable life form that we call bio-nanohybrids. Under a microscope, bio-nanohybrids look like stubby pretzels with salt crystals attached to the surfaces, but the crystals are actually nanoparticles generated by the microbes themselves. Salt adds flavor to a pretzel, and we can design the nanoparticles to do a whole lot more. In effect, the microbes can interact with their environment in unprecedented ways. Here's one way. Microbes that are resistant to antibiotics have significantly increased the burden of care in our hospitals. We have induced one of the most resistant microbes to generate these bio-nanohybrids, and that's opening the door to a whole new class of treatments that target only the pathogen. That's transformational. I want to share one other transformation with you. Me. This chair program gave me the freedom to approach research in a way I'd never imagined before. We started working in exploration mode, and that resulted in what came to be known as a discovery to impact pipeline of inventions and patents and startups, and students and postdocs trained in innovation and entrepreneurial thinking. The greatest impact of this chair program will come via those students, and the students who are getting hands-on experience of research aimed at innovation in the undergraduate course we developed, along with the future students who will gain this innovation mindset as we expand these opportunities across our university. They're the ones joining and running the startups. They are the ones who will implement the energy transition during their careers. They're the ones who give me hope. Hope that our legacy for future generations will include, above all, the necessary knowledge and experience with innovation to change their world.